log into their computers. No, don't go to Blackboard. Just log into your computer.
Welcome. Get it up.
Huh?
Turn it on.
No, log in. You're on a network. You got to log into a network.
All right.
Username is MEPSTU and the password is welcome. Just like when you take a test. Yeah, our department runs their own domain, so it's not, if you log in like to Blackboard, it's not your same Blackboard account. Everybody logged in? Okay, so somewhere on your desktop, you have a NXT 2.1 programming. Don't choose the data login. It uses the same icon. Choose the program. And then double click on that. Now this is our offline programming for the Lego robot. It's called Mindstorm NXT-G programming language. And this should be the way it loads up. If you hadn't got it, then move next to somebody that does see it. So what we have right off the bat is we have getting started. You don't need to look at that. We're going to step you through everything. Right here where it says start a new program, this is where you will type in the title of your program. Okay. So right now just type in your first name. We're not going to save it anyway. And then click on what? Now, as you develop your programs, it's going to say open recent programs, and there'll be a list of the programs that pop up there. So as you go through, you won't have to constantly remember the name of these different programs because this is where you'll pick it up at. And then just click on go.
So in experiment one, type in your name.
What do you experiment one? Well, this is not an experiment. This is just learning how to use the software. Now this is NXT-G programming language, and it's a really, really neat language. If you're going to learn how to write programs or try to teach your children or the process or the logic of writing a program, this right here is great. So this little robot teaches you a lot, even though they try to make it as simple as they possibly can. Now notice on the left, we have a group of boxes, or they call them bricks, because this is basically, we're going to build this kind of like we do a Lego. And down here we have what we refer to as a rail. So what we do is we have 3 motors and we have 3 motor ports, and the motor ports are labeled A, B, and C. Okay, so what I want you to do is just come up here, the top one, this is motor. This is continuous path, which we're not going to use. This is if you want the robot to say a set of terms that's already in the robot. This is if you want something to pop up on the robot's display. This is where we're going to get to our sensors and also a timer. This is where we're going to make the program loop. Everybody okay with that now? This one is we're going to make the program make a decision. Okay, move to it. You didn't hear me. If you're having problems, move to somebody and look on them and see. Because we don't have. And then we'll look at it and see what's going on later. So what's the top one on the left? Motors. Continuous path, which we're not going to use. If you want the robot to say something, right? This is if you want to do what? Display something. This is for one of our sensors. This is if we want to make the program loop. Everybody okay? And this is where we make decisions. Okay, we'll have if you've ever been into programming, when you make decisions, you make 2 decisions. You say, okay, go this way if it's true, or go this way if it's false. Okay. So let's click on the motor. Y'all, you don't have to, when you do this, you don't have to drag it. All you got to do is just click on it, and then you can start moving your mouse around. Now, where the block is going to be inserted, can you see the little gray right here? See the gray right there? That's where the block is going to be inserted. Just put it on the gray and then left click again, and it should insert it in there for you. Are you okay? Now notice when you did that, down at the bottom, you got the controls for that block. So what can we do with this block? Well, we can select which motor to run. By default, it's going to come up BC, which is okay because these are going to, when you build your robot, these are going to be the 2 drive motors we use. But when you get to the end of the sensors lab, it's going to have you write an offline program. And what you're going to do is you're going to look for a sensor and run a motor, look for a sensor and run a motor. So that way we can see if you understand how this goes. So what can we do with this? We can select the watt. Okay, we can select the direction, or we can stop the motor. So that would stop it. That would actually put the brakes on. Down here, we come up here. We can steer left or right. Okay. Where's my slide at? It's covered up, I'm sorry, by the box. Let me move this down just a hair. Okay, so here we can tell which direction we want to steer. Okay. Understand that? That makes sense. Over here we set the watt, the speed, in percentage, by the way. The problem we have is that when it says 75, that's a percentage of the maximum speed the motor will run. And sometimes what happens when you get these 2 motors, they don't run at exactly the same speed. So we'll show you how to compensate for this. So sometimes if you want the robot to go straight, it might drift to the left or drift to the right. And then we'll show you an easier way to do that. Then what we got the ability to do is set whether we're going to do closed loop or open loop. Okay, so right now by default it says we're going to turn the tires how much. Now how far is that going to be? Well, it depends on it's going to depend on the diameter of the wheel, right? Y'all understand that? So you could calculate the circumference and then figure that out. Let's click on that and see what other options we have. So if I don't want it to make 1 full rotation, then I can specify the number of degrees. So there's no such thing as 1.5 rotations, but if I wanted to go 1.5 rotations, then I would do what, 270 degrees. That makes sense? Then what do we have next? I'm sorry, what's first? Unlimited. Now, what we mean by unlimited is what we use unlimited for is this is where we establish what is going to stop the motor. So anytime we use unlimited, we're going to use this including a sensor. Does that make sense? So let's say I come up here and choose unlimited. And then I come up, then I come up here. What I'm going to do next is I'm going to put a sensor in there. So what's going to happen when it moves into this block, it's going to turn the motor unlimited, and then it's going to go to this block. Right, you understand? And it's going to wait for what?
Command.
It's going to wait for that. So we've already given it the command or the instruction. We said, okay, we're going to use a sensor. We're going to run this motor until this sensor is true. Does that make sense? So we're going to run these motors unlimited until the sensor is true. So we can't really call this a open loop because now we're running it until we see a what? A sensor. So what you're going to do if you use unlimited, what's going to be the next block? It's going to be the sensor that your controller is going to look at to determine when the motor stops. Or the motors, because you can run all 3 of them if you want to. Y'all understand that? So right now, let's look. So here's touch sensor. And it says, okay, I'm going to do the touch sensor. By default, it comes up. So when you build your robot, or even when you do the sensors lab, you're going to hook the touch sensor up to port 1. So by default, y'all know what default is in computer. What is default? if you don't change it. So that's what a default is. The default is what we use, what the computer uses, because computers have got to use something. So most of the time when you come up here and you put a command in there or an instruction, it's going to put a set of defaults in there. So notice when I selected the motor, it automatically selected B and C. It automatically selected going straight, and it automatically selected what? 75%, right, and 1 rotation. And stop instead of coasting and stop. So here when I put in my touch sensor, it come up and said what? It's okay, the sensor, it automatically said what? And then it said it's going to look for it to be what? Press. If we select the other one, it's going to look for it to be what? Release. And what do you think bump means? That's like you hit the key on your keypad. So you don't hold it down, you just bump it, right? You understand? So it's not, it's going to look for it to go, it's going to look for it to be pressed, and then it's going to look for it to be what? Released before it does it. Does that make sense? All that makes sense? Yes or no?
Press means hold. Hold. No.
No, press means just hit it.
Just hit it.
Yeah. If it stays, because this is not looking for it to be held, this is looking for it to be pressed. Okay, so what happens is as soon as this hits something, then what's going to happen? So this is going to run the 2 motors unlimited. As soon as it hits that thing, that tactical sensor or that pressure or that touch sensor or limit switch, whatever you want to call it, then what is it going to do? Well, it's going to go over to the next block and do what the next block says it to do. But it's going to run it unlimited until it sees that sensor, right? You understand? So if we just said run unlimited, what's it going to do? They're going to take off and run into walls and all kind of stuff, right? You understand? Because, so anytime you use that unlimited feature on these motors, you're going to specify what? The next block is going to be a what? A sensor. Yeah, you're giving it feedback. So you're saying go to here, right? Or hit this, or look for the ultrasonic sensor. Well, bumping is actually requires a release. A press does not require the release. So when you press it, we're looking for it to be pressed, right? You understand? If you put bump, it's not only looking for it to be pressed, it's looking for it to be released. So if I was going to back into that wall and use my touch sensor and I put bump, it'll hit that wall and just dig into it. Because it's looking for it to be what? Released. Okay, but if we say pressed, if it hits the wall, then that it's not looking for it to be released. Even though it will go through the next block. Okay, y'all understand that? That makes sense? Of course, this is a digital sensor. So all we're doing is looking for it to be pressed, or we're looking for it to be what? Released, or we're looking for it to be bumped. Everybody understand that? Now if we wanted to display something, by the way, notice, can y'all see the blue around here? This is the block that this table down at the bottom belongs to. Y'all understand that? And this is the way we select a block. So if I don't like that block, I just select it. All I do to select it is just click on it, right? And then it turns blue. And if you want to get rid of it, just hit the delete key on your keyboard. And it's gone. That makes sense? If you want to move it, then you have to do a drag. So if I want to move it, I would highlight it. Y'all know how to do a drag? How do you do drag? Press and hold the left mouse button, right? And then I can come up here and I can drag that. Now notice the little gray slot. Can y'all see it? Okay, I'm going to come over here and move it if my computer, and notice the gray slot move to the rail, and I can come in and stick it right there. So that's the way you can move blocks around. Everybody okay? So everybody sees how to delete them. If you come up here and you put the touch sensor and you say, well, dang, I didn't want the touch sensor, I wanted the light sensor, then what can you do? Come down right here, see this? Okay, and just come down here and select the what? Light sensor, and notice the symbol change. So what that means, if you use the wrong sensor or whatever, then you can do what? You can change it without deleting this one and doing what? And now the other one would work fine too. If you deleted one and drug a new one in, that would work fine. Everybody okay? I highlighted it and clicked on the delete key. Yeah, are we okay? Everybody okay? Any questions so far? Pretty straightforward, by the way. By the way, this thing has a really high programming language. What we're going to use is what they call the common palette. So don't get into this palette right here, because we're not going to teach that. If we really taught NXT programming, which we don't have enough time in this class, then we would spend more time in this palette than the other palette. This is where your compares are. This is where your math functions are, and we just don't have time to do that. But every real high-level programming language has logic. So it says if this and this is true, or this is true. Every programming language has compare that says if this is greater than this one or less than that, right? You understand. Every programming language has math in it, so you can add registers together. But we don't have time to get into this. But if you bought one of these things, this would be where the real power. So this is like taking, if you're taking PLCs, this is like taking what we call advanced PLCs to get into the real high-level language. We're going to use this common palette. Every program that we write in this class, we can do with the common palette. So let's come in and look at, so we're not going to use this one. You can make it say whatever you want to. So let's I'm going to pull this in. Okay. And we can make it say what? Good job, goodbye. So these are the ones that we're using. I don't know what format they're in. I think you can actually record something, and we've never used this, but don't do that and actually load in a file. I don't know what type of audio file it is. Are we okay? Let me step back just a little bit. I should have showed y'all this. So what you're going to do is you're not going to store these programs all on my computer. What do you think you're going to store them on? On your thumb drive, right? Okay, y'all understand that, or flash drive, or what you want to call it. And this, by the way, these are desktop computers, and the chassis is down inside these little doors beside you. There's 2 USB ports available. So what you're going to do before you start, of course, is you're going to stick this USB drive in your computer. If I was to save this right now, it would go to my hard drive. So one of the first things I want you to do when you create a program is to go up here. Let me move my thing back up so it gets recorded. Is to go up here to where? File. Yeah, then you're going to click on what? Save as. Don't click on save, because if you click on save, it's going to save it to the default, right? And where's the default at? Now it is. We're fixing to change the default. I'm going to put save as. And then it says, well, if you don't have a USB drive in there, just follow me, make a little notes. Then you're going to say what? Browse. Okay, and then what you're going to do, no, you're not going to create a file. You're going to go what? Computer, and then look for your what? Look for your thumb drive. On most of these computers, it'll probably be either drive D or E. I can't remember which one it is. It usually is E on my computer. Now, once you select that drive, then from now on, if you say save or you exit the program, it's going to go to your specified default, right? Y'all understand that? So when you look it up, just so you don't forget, as soon as you open a new program, you have to do this for every new program, right? Now, once you've pointed a program to your thumb drive or your USB or flash drive, whatever you call it, it's going to use that as the default for that program. But every time you create a new program, the first thing you need to do, even before you start putting blocks, is do what? You need to save it. Everybody understand that? So I don't have my USB thumb drive in there, but
Each program save at the same time.
No, as soon as you create it.
As soon as you create
So as soon as you give it a name, y'all listen up. So as soon as you give that program a name, and then you say go, and it loads up and gives you that blank screen, first thing I want you to do is say that, right? And then do what? And then point it to your USB thumb drive, right? Save as, then you choose what? Browse, you choose what? My computer, find drive. You can only do this. No, you can't because you don't have administrative rights. Y'all don't have administrative rights on this computer. Y'all have basic user rights. So that means you try to install the program on the computer, it's not going to get you to do it. The only person that right now, Ms. Wilson, the only person that can make it.
You gonna unlock them? Cabinets here too?
They're not locked. They're not supposed to be locked. Somebody, for some reason, I don't know what it is about guys, but guys can't leave things alone. So it always surprises me why people want to take a knob off.
Well, one side is not locked, but the other side.
So I think there's super people up here that take the knob off. Okay, are we okay? Yes or no?
Yeah.
Everybody okay? Everybody okay? Okay, so let's examine some of the things we can do. Let's bring in one of our other sensors. So if you're going to use timer's open loop. So I can say run the motor unlimited, but I say run it for 5 seconds. Now that is open loop. But if I say run the motor unlimited and then I wait on a sensor, then that's closed loop. That makes sense? I wasn't quite right when I said that while ago. So timers, I'm going to get rid of that. We're not probably use that this semester. But let's bring in our light sensor. Let me move my block back down so I can pick up what we got. So now it takes for granted that this sensor is hooked up to what port? 3. Now the light sensor is an analog sensor, but the brick does not recognize analog, so it's got these little A to D converters in there for every port. So what we get the ability to do right here, see the slide right here? This is where we're going to set the sensitivity of the sensor. Y'all understand that? So by default, it sets it at, it says the reflective light or the light has to be greater than what? 50%. So this is where if I wanted it to see my golf ball or my plastic ball at a 1/2 inch, then I would move this, I would take it and put it on the tee, right? You understand? I would come up here and put my thing a 1/2 inch. I would use what option on the controller? Starts with a V. I'd use view. I would look at the sensor and I would see what it puts out at a 1/2 inch for the red ball. Or if I could do the same thing with the wall. We got 2 colored balls. We have what? Red and blue. I usually use red because the light source is red. And once you set that up and you get that setting, you come into your sensitivity and you enter that and say, okay, I want my reflective light to be greater than 10%. And as soon as it gets up there and sees 10%, what's it going to do? Well, it's going to go to the next block, right? You understand that? And then that's where we'll stop the motor. We'll give it a little delay when we do our driving range. And do what? Hit the block. Yeah, we don't want to go from the block to swinging because the robot, right? We want to stop the block. We want to stop the robot. So I can set it up for ambient light. So if we turn off the light source, y'all see generate light? Then the light sensor is looking for ambient light. If we turn on the light source, then it's a diffuse sensor and it's looking for reflective light. So I don't know what we would, none of our labs are going to use ambient light, all ours are going to be reflective light. You turn off the light source, then the sensor is going to look for ambient light. You know what ambient light is? Yeah, I've already out. If we turn it on generated light, then it becomes what we call a diffuse sensor. So now it's looking for what? Reflective light off the object that we wanted to detect. If I use the ambient light, you tell it to follow that line over there, and I've got my light sensor pointing down, it's going to run all over. But if I wanted it to go forward when I turn the lights on, then I would point my light sensor up, right? You understand? And then I would turn off the lights, and then when I turn on the lights, it would take off. Or if I had a little light on my phone, and I wanted it to stop until I turned that light on, then I would set it up for ambient light, and then I would get in front of it, and I would put my controller on view. So looking at the output of the sensors have nothing to do with this program right here. No, there is no such thing as an ambient sensor. Yeah, so what we have is we have a light sensor. It won't come on and then it's going to look for reflective light. But we can do two things. So I could make it come up, and when I turn on the light on my cell phone, it would take off, and when I turned it on, it would stop. We can do that. But how would you know how much light to do? Well, what you would do is you'd measure it using the what option? The view option on the controller. And then you would come in here and set that sensitivity. So that way, it wouldn't take off with these lights, because these lights wouldn't be bright enough, right? You understand? But they would take off with your light. But we're not going to use that option, but that's what we're going to do. So ours is going to be generate light. None of the programs, unless you're just screwing around, would require this. Of course, you're going to have so many things you're going to have to do, if you get through at the end. So if you got an Android phone, no, never mind, I'm not going to tell you. You can actually run the robot from an Android phone. You can't do it from an iPhone, but you can from an Android. Not unless they put the app up there. But it's pretty neat. You can't program it, but you can run it kind of like a remote control robot. So all these sensors, like sound sensors, we have the capability to set the sensitivity. And by default, it's going to come up set to what? Except for the ultrasonic sensor is set for inches. So the ultrasonic sensor says it's going to be set up for less than. Because usually the ultrasonic sensor, we're not looking for something way out there. We're saying, okay, if I get within this range, do something. If I'm not within that range, do something else, right? That makes sense. So this says greater than. So this one says what? Less than 50. So if I wanted my robot to turn at 6 inches. By the way, this says 6 inches. But what I would do is I would come over here and I would put my robot 6 inches. And then I would measure I'd use the view to see what that sensor actually puts out. Because understand it reflects, but it depends on what it hits, how absorbent it is the same. We have some pretty good surfaces in here, so we don't have a problem. So the first program you're going to write, is all you're going to do once you finish the sensor layout is you're going to go back and you're going to write a little program to make these motors do something for every sensor. Does that make sense? So that way, light sensor, I might turn on VC forward. When I do the sound sensor, I might turn on C in reverse, right? Y'all understand that? Just to get a little feel of it. Now, we have Bluetooth capabilities on the, so if you bought your own robot, odds are, and you have Bluetooth in your laptop or whatever, odds are you download this in the robot. It's using Bluetooth. We don't have Bluetooth on any of these computers except for mine up here. So that means you're gonna have to download this using the USB cable, or obviously everybody in the back won't be connected. None of these computers out here has Bluetooth cable. So we use a USB cable, the A and the standard B, the original big B. Look at your brick, you'll see brick is what we call the control cable. It's got a USB connection. So you hook it up to the front of the computer. You have 2 ports in there. By the way, do not hook your phone up to these computers. I think I've already told you that. You want to charge them on another port. So if I want, this is once the controller is hooked up. I don't know if this does. Of course, we've given the program a name. And let me get my USB. We'd hook up to one of our USB ports. You might wait a little second. Your controller has got to be turned on. You can't download with the controller on your robot turned off, right? What's going to do right off the bat, it shouldn't have to do it because these things have been used, but it might have to install the driver. Then we have 2 options down here. On the left, we have a download, and we have a download and run. I don't want you to use the download and run. Can somebody figure out why? We've had this, we don't want it to run off the table. We've had people do this before. They have the robot built, they set it up here on the little table, right? They use download and run, and they're over there on the computer, and the dang thing jumps off the table. So what we're going to do is the download. Y'all can't do this, but should hear our robot beep when it's finished. It should come up and give us a message, tell us that it's in progress. And if it comes up and pops up and says, I can't find the controller, it means we don't have the driver, and we'll just have to figure that out. So it's in the robot now. So what are we going to do? By default, it comes up to what? My Files. I'm going to hit the what to select that. Orange button. Then it says Software Files. I'm going to hit the orange button. And these are all the programs that you put in here. Okay, which one did I say? Rich. Okay. Now how do we think we load that in? Orange button. Now, how do you think, this is where we have an option of deleting it. By the way, if you delete it off of NXG, it does not delete it off your robot. Okay? So how do you think we would delete it? Well, we'll just move over to the little, I'm using my keyboard on my computer. I'd move over to the what? Delete. Hit OK. Hit that. It'll come up and say, are you sure? Okay. If I want to run it, I hit it again. And that was the program. Notice I picked it up off the table. And now now I didn't tell it to loop, so what did it do? It just ran to the end of those blocks and just did what? Of course, it's probably waiting on something. What was the first one? The touch sensor. I don't know the program. And that's all there is to it. Yeah, I don't remember what it did. Yeah. Oh, I want to. Yeah, I hear it say something. I don't know if y'all heard it or not. So now it's probably waiting on another sensor. I don't know which one it is. I'm gonna set it. By the way, normally when you set this thing down, I'm gonna stop it. Now to stop it, if you got it in a loop, if you got it in a loop, you could stop the program on a sensor, right? But we're not going to do that. Then what you do to stop the program, pick the robot up and just hit the gray button, and then that'll stop the program while it's running. Because most of our program will end up doing what? Looping them. Especially when you follow a line over there. That's what you're going to do. You're going to be in a loop, right? When you drive the golf ball, that's not going to be a looping program. You'll just run it up there and hit it one time. When we do a free roam program, it's going to be a looping program. And remember, this is where you go to view, and then what do you have to do? You select the sensor, and then you're going to select the port that the sensor's on. So what it means is I don't have to use the default ports. So I can buy sensors for this thing. These are the number of sensors that this robot supports. So we can receive a message, we can go to the rotation sensor, so we could actually go to the encoders on the motor and read those things. We could got a color sensor, which we don't have, but you could buy one. Now it could sense colors. We have a light sensor. We could actually do things with the buttons on the controller itself, the NXT buttons. We could receive a message. We could go to the rotation sensor. I don't know the difference between this and this one. We could use a sound sensor, temperature sensor, which don't come with our kits, but you can buy these sensors from Lego, or you can make your own, by the way. Timer, touch, ultrasonics. I don't remember what the emitter on and emitter off. Oh, this is Bluetooth. So we could literally turn on the Bluetooth and send something out, right? You understand, and turn it off. So we can make these controllers communicate with each other, which is pretty neat. So this guy, where's it at? I'll get the program. I'll run the program. That's what this guy. That's what we're using on this program right here. So this looks like a radio controlled car, but these are two robots. And what we're doing is they're communicating with each other using Bluetooth. So we got a little controller we drive it with, and we got the robot itself. Which is pretty neat, but how are they doing that? They're doing that through what? Leaving early? Oh, okay. So you can do a lot of neat things that we just don't have time to do in this class. We could probably teach a whole semester on just writing programs for this thing, which is pretty neat. Okay, is everybody okay so far? Okay, so let's look at looping. Now, let's do it this way. Let's say I decided I wanted to make it loop. This is loop control right here. And now, but the problem is that all the bricks that you want to be, or blocks you want to be inside, it's got to be inside the loop, right? You understand? So how can you get them in there if you decide to put them in there later on? No, just drag them in there. See? So you can come in here and drag them in there. But if you know you're going to do the loop, then go ahead and put the loop command in there first, right? You understand? Yes or no? Okay, so I can drag them in there. Normally what we would do is we would come up here. Normally what we do is we don't want the program to take off and run. And sometimes it's hard to see the display when you got it down on the floor, right? So normally what we do to run a program is we start it off with a sensor. The sensor is outside the wall. Does that make sense? So that way I can put it down on the floor, I can get up, and then I can tap my hand drill out and use the sound sensor to start the program, or I could use the back little limit switch and get that. Normally we don't use the ultrasonic sensor. Normally people like to use the little touch sensor on the back. It's going to be on the back of our robot. They like it. No, you start it before you look. Oh, you're probably saying it right. So what I would do is I would come up here and I'd take a sensor, and let's say I want to listen to sound, I would put it right there. And then I would come up here and I'd put my loop at the next block. Yeah. So then I would come up here and I would start working with what I want to do. So let's say we wanted to make a program that just free roams inside. Y'all know what free roam is, right? Everybody okay with free roam? What's free roam? A lot of mobile robots come with that program built into it. Free roam means we just come up here and the robot just roams around. But don't run into stuff. Let's see if I got a free roam program. I don't have a free roam program never. I don't think I got it. Well, free roam would mean you just let the robot go, and then it just goes around and it sees something. Which sensor you think you're going to use? Probably ultrasonic, not the light sensor, because we got so many shapes. And then when it sees something at a certain distance, what would you want to do? Stop it? Not necessarily turn. You got all the hardware in front of it. The normal way is back it up and then take off on the other direction. So we'd run it, then we'd use what sensor? Probably the ultrasonics. Okay. Then when it saw it, what I normally do is I come up here to keep it from having any problems. What I normally do is I put a block in here and do what right here? Stop it. Yeah. Then I come up, then I would probably do what? Stop it. Then I would do what? Back it up. So I'm going to come over here on BC and I'm going to put what? Tell it to go backwards. And then I'm going to turn it. And then I'm going to do what? Well, I don't have. I've already stopped it. We could stop it. Yeah, let's do that. Okay, so what else would I do? Well, first of all, we need to go to the ultrasonic sensor, and if we let it set for 50 inches, that's a long way. So let's come up here and make it just. We're not going. Let's make it 10 inches. By the way, you can enter it directly if you want to. Okay, what do I need to do now? So here we go. Let's follow the program. It's going to run straight until it sees what? Then it's going to do what? Stop. Then it's going to back up and turn. Then it's going to do what? Stop. And then what it's going to do? No. Then what? Okay. Then what? It's going to loop and do what again? Go forward. So to me, it looks like that's all I need. So this is still called Bridge. So we're going to overwrite that program. Oh, it says we're out of memory. And this is, we're going to have a lot of programs in here, so it's basically when you start doing your competitions. So if you run out of memory, you need to go out and do what? Delete some of them. I'm not going to do it on this robot. I don't want to delete any of those programs. That's a lot of the programs that we have. This robot is low on power. But let's see if I can put it in this guy. My file, software, rich. Okay. What's the way down?
Well,
It's real low.
Yeah, I don't know. The battery. It did, but as soon as you turn the motors off.
And it just doesn't do that.
Huh?
It just doesn't do that.
The battery lights like. Stop it, I'm just trying. So y'all see how you do this? Y'all understand loops? Oh, by the way, if these guys pop up, this is the power of the language. We can pass information from block to block. It's really, really neat. Like I said, we don't have time to teach these hubs. So, I mean, this is a very powerful language. If that pops up, just go up, back up here to, you see where it turns into the little double that line up there, and just hit it and then cross it up. So don't use those little hubs, because that can cause you problems. But it's real neat. We can pass speed information. We can pass output from our sonar sensor, our ultrasonic sensor. We can put that into decision blocks and make some really, really neat programming languages.
Talk about the other tab.
Huh?
Talk about the other tab here.
What?
Below the,
Yeah, that's the one we just used. This is loop. Okay.
I mean, below that.
No, that's what we're talking about now. This is our what block? By the way, if you, for some reason, we don't have to do this, but if I come over here and click on this guy right here, loop, look at the options. So right now it's going to loop for what? Forever. We could say, okay, I could change it to loop until the sensor becomes true. Or I could say loop it for 15 seconds. Or I could say loop it for 32 times, right? You understand that? Or I could say look for logic, this and this. So if this sensor was true and this sensor was true, it would keep looping. We're going to leave ours on what? Forever, yeah. Here's our decision-making block right here. And by default, it comes up with which sensor. So we have two paths we can take. We got this top path, okay. And then we got this bottom path. Now over here, and this is decision. So decision, it says, okay, if this is true or if this is false. Y'all understand that? So can y'all see the little arrow right there? Okay, so here it says if it's what? Pressed, then we're going to run this line of code. And then when it gets through, it's going to drop down and come back out here, right? You understand? If it's false, it's going to run what? This line of code. Yeah, okay. These are code instructions. So we call them lines of code. Sorry. So this is powerful. So if I want to make it, if I wanted to make it follow a line over there, how am I going to do that? The white line over there. Okay, we're going to use a light sensor. Which way are we going to point it? Down. So we got two options on your light sensor. We point it what? Out. So we're going to point it out when we look for the look for the plastic ball. When we follow the line, we're going to point it what? Point it down. It's got the mouse on there, and all you have to do is just pull it off and stick it back on the other direction. Then what I'm going to do? Oh, by the way, this is the way you avoid. This is the way you compensate if your robot drifts. And this is what I like to use right here. I'll come up and use two motor sensors, and then I'll set this. And your drive motors are going to be what? B and C. Well, what I would do is I would set my first block to be B, and I'd set my second block to be C. So what happens, if these are unlimited, not one rotation, if it runs one rotation, then what it'll do, it'll finish one rotation, and then it'll move to this block, so your robot would do this. If I come up here and say unlimited, it comes flying through these boxes and goes to the next sensor, right? Does that make sense? And then what I can do now is instead of doing this, what I can do to control how fast it turns is to change the what? Speed. So I can change the speed of like the left-hand motor. If I slow it down, then it's going to drift back toward the left. And you can do it in increments of 1. This is almost impossible to do with this slide over here. It's almost impossible to do. So this is what I like to do, huh?
It take a while to figure out how much to slow it down.
Well, no, it's instantaneous. I don't know what you mean. I mean,
To match them up. You get what I'm saying? To match the,
yeah, but when we're over there following the line, it's up to you. You can do it either way. You can use the turn, but how you going to win the competition? You're going to win the competition by the fastest route. So you get credit for getting it done, right? You understand? And then, but to win the competition, it's going to be a race. So what we need to do is you need to be able to trim those speeds to be what? As fast as you can possibly make them. And this is the only way to do it. So it's, huh? I wish. We did that for our summer camp, but that's not summer camp. Those robots were bought by a grant. And
each of us got right for the program, or is it?
it's going to be a combination of them. That's the only way we can do it. So y'all work, but you got to work together. I don't want to see one person over there programming and the other guy out there smoking a cigarette or something like that, right? You understand that? Y'all understand that? So what we do, this is, oops. Oops. I don't know what I just did. Okay. So this would be a basic follow the line program. So what I would do if I wanted, here I would want it to turn in one direction. So I might set B to 50% and C to 80%. And then what would I do on the other ones? I just swap them around. This one, we would calibrate this one to see, I'm sorry.
If the program follows the right line, we're not necessarily like the program turns, and it will turn itself, right? When it loses.
The robots don't do anything unless you tell them to do it. So just because it sees the light, you have to tell it which direction to turn when it sees this color and when direction to turn it sees that color. Right? Understand? We don't tell it to follow the line. We don't tell it to follow the line. We do what, Robert?
They're not.
We program it to follow the line, right? Y'all understand that? So what we would do is we would go over there and how am I going to calibrate my light sensor right there? I'm going to take it over there and I'm going to do what? I'm going to put it on the white. I'm going to record that. I'm going to come over and put it on the gray. I'm going to record that. And where am I going to set my light sensor at? I'm going to set my light sensor. What sensitivity I'm going to set my, somebody said it. In the middle. Right? You understand that? And we say, okay, if it sees dark, if it sees below that, which means it sees gray, then it might follow this line right here. If it sees above that, which means light, oh, I'm sorry, this is light up here. If it sees below that, then it'll follow this line right here. If it sees above, if it sees above that, did I say that right? If it sees above that, it will follow this line right here. If it sees below that, it would follow the line right here, this right here. So if it follows this line, I want to turn it toward the gray, right? If it follows this line, I want to turn it back toward the what? Toward the white. So the robot is not going to actually follow the line, it's going to follow the edge of the line. To follow the line, we would have to have two light sensors. And what you'd do is you'd set them at the width of the line. So if this one saw gray, you would turn it. If this one saw gray, you'd turn both of them back toward white, right? And you can make this robot fly. Ours is going to go kind of slow because it's going to be doing what? It's going to be wiggling back and forth. And the steeper you make that wiggle, the slower it's going to be. And what you want to do, you want to play around with those speeds so it just comes up and does what? Bounces down the side of that line and still has enough to turn the corners. And that's the way you trim this thing. That's a basic follow the line program. And you think it's complicated, but it's what? It's not. It's not complicated. So it's just you reasoning them out. So we're going to drive a golf ball. What else? We're going to free roam. What's free roam? Just roam around here. Don't run into anything, right? You understand that? And you don't have to make that real fancy like the one on this robot that actually looks and figures out which direction to go. What you'll do is you just hit something and do what? Once you see something, do what? Back up and go off in another direction. We're going to free roam inside a boundary, which is basically the same. We're going to follow the line, driving range, and a maze. I'll have to show y'all the maze. And it's not a complicated maze, but it's still hard because if you got any, it's a pretty good length maze, and if you don't set your robot up right to start off with, and then it'll be off at the end, right? All right.
Monday, right? We've got test next Monday.
So what?
I'm saying that's all we got.
Build the robots and compete them? Yeah. Oh, we got Wednesday. We're not. Yeah, we'll start. By the way, remember Wednesday's test is going to start when? First of class. We're not going to do it at the end, and then we'll be on lab after that. And depending on how it works, we might even do some lab on final one day. Are we okay? And by the way, so what we're doing when we start building this, some of y'all are doing your sensors lab, but that don't take extremely long. So when you build this, what you probably need to do is, because like Robert said, we don't have a lot of time, but you're doing it as a what? Team. So what you need, by the way, the building instructions are also on Blackboard. So I know you've only got one book, but it's also on Blackboard. Now, when you get it signed off, you're going to get it signed off one section at a time, right? You understand? But the way y'all can work is that one person's building this, and then the next person is already putting like the sensor together, and then when you get that checked off, you have to come up here together, right? Everybody's going to have their own lab and their own lab form. And you're going to come up here, you're going to get it signed off, and then you might just be able to do what? Go over there and attach the sensor to it, and you come up there what? Yeah, and get it signed off, and then work on it that way. But only one sign off at a time. I think there's 6 sign offs. The lab is worth 50 points. If you come up here and you have a completed robot, which would be sign off number 6, then you got 1 or 2 options. You can tear it down and start all over, but then you'll never get through. Or you're going to lose the points for those other 5 sign offs, right? Which is going to be a lot. So it's going to say, stop at this page, get a sign off. Stop at this procedure step, get a sign off. And if you just decide you want to build the whole robot, then fine, you'll end up and get a 0 on that lab, but you can go ahead and start competing your robot. Y'all understand that? Yeah. So when you look at that thing, and I know some people gets involved and they'll fly, but if it tells you to enter that online program, then that's time for a sign off. Everybody understand that? So it says enter this program, then enter the program, go out there and see what it does, and then say, okay, I'm ready for a sign off. By the way, we do have some problems with some of those online programs. Those online programs. When we say online, what are we talking? We're not talking about internet. When we say online programming a robot, what does that mean? We're programming on the robot, right? I understand that. The program you're going to write a program that makes it change directions when it hears a sound. The problem is that online programming for this robot is very fundamental, right? Only 4 blocks and then plus a loop or a stop. Okay. So the problem is we can't set the sensitivity of the sensors. So a lot of times when you enter that sound program, it'll work okay when you're holding it in your hand talking, but when you put it down on the floor, it'll start jerking back and forth, back and forth, back and forth, back and forth. What it's doing is it's picking up, once you put those motors on the ground, they're a lot louder, right? You understand? Because it's picking up the sound. The motors start loading, they put a little more sound out. So what you need to do is sometimes you need to do it by holding it in your hand, hold it real good. And it's supposed to go forward, I think, and then when it hears a sound, it's supposed to back up. And then I think when it hears a sound, it's supposed to go forward again. We'll pick it up and do it. There's one where it's supposed to follow a line. You cannot follow a line with this offline program. So what you need to do is you set it down on the floor or try to put it on a line, it's just going to jerk around or it's going to miss everything because we can't set the what? Sensitivity. But you should be able to have something black, and if you put it this one and it turns this way, you take it off and the wheels turn that way, you can see it, then it means the program's working okay. But once we get into online programming, we can do what now? Offline programming, we can do what now? We can adjust the sensitivity, and it shouldn't do that anymore. Everybody okay? Okay, guys, y'all take a break if you want to. Let's go to lab.